Alright, let's talk about capacitance. So, in the last video, we showed that if you have a battery and you connect a wire to it, you can build up a positive charge, and that positive charge creates an electric field. Now, I was wondering, what if we took another wire and we connected it to the negative terminal? Then we could maybe do something like this, which is a negatively charged piece of metal going around this wire, and would the charge then be more because these positives are attracting these negatives? And what we call the term that we can use here is called capacitance, and capacitance means based on the voltage we put in, what is the charge that we're going to get here? And the charge meaning this wire has a positive charge and this piece of cylinder is going to have a negative charge. And so we already have an idea about the charge, and now we need to figure out the voltage. Well, the voltage is, say that we have our red wire like this. It actually has a radius, and we have our thing going around. Call this one B, this one A. Then we know that the voltage is going to be the difference in potential, so that's VB minus VA. And the difference in potential, just like you have the difference in potential energy is force times distance, the difference in electric potential is going to be the integral of the electric field times the distance. So, yeah, and remember that's a negative as well. So if we take the integral of from RA to RB of the electric field, and let's say the radius, so we make a straight line in the radius, then we should get the voltage. And hey, we already know what the electric field is coming out of here because we just figured that out in the last video. That's going to be Q over 2 pi epsilon L R. That's for this here. That's the LR for the radius. And a bunch of this comes out. You know what the limits are here. And if we just integrate that sucker, then we're going to get this. So, let's look back to our formula for capacitance. It's the charge over the voltage. Here we have the voltage in terms of the charge. And if we substitute this in, 2 pi epsilon times the length. See, it depends on the sizes of the dimensions as well. And this is the formula for capacitance for a cylindrical capacitor.